recording. Okay, in the last lecture, we have seen definition of robot and history of robot. Now, today we'll see major components of a industrial robot and specifications of robot. Therefore, in the diagram, it has been shown that different robot components are there. They are divided into three subsystems. First is motion subsystem, in which actuators, end effectors, joints, links are there. Then next is the recognition subsystem, in which sensors of vision, audio, distance, pressure, etc. Then next is the control subsystem, in which power supply, controller, software, and central processing unit is there. Therefore, whatever these different parts of the robotic system is there, it is divided into these three subsystems. Therefore, we will see one by one. Here you are observing that this is the wheeled robot, because wheels are there. It is mounted on the base. This at the end of this robot arm, this is known as gripper or end effector, similar to our fingers. We are knowing our fingers are used to catch or to grab anything. This is the arm of the robot. Now this is the recognition system. This may be the camera, which is connected to the computer here. Here sensor may be there. Now this is the object environment or platform on which objects are kept. I will see one by one. First is power supply. Just like human beings consume food when they need energy, robots need energy to function as well. Most of the robots receive their power from electricity. That is, robots are mostly now they are electrically driven, means motor is used, either DC motor, AC motor, or servo motor. Then stationary robots like those in factories receive direct power just like any other appliance. Mobile robots typically sport high capacity batteries. Batteries are also used for driving the robot. Now you are knowing that many students are there. They are taking part in various competitions, that is robotic competition. Therefore, they are using these small wheel robots, and for that they are using the small batteries. Then robotic probes and satellites are generally equipped with solar panels for harvesting energy from the sun. This solar energy is also used to drive the robots. Now next is the central processing unit. The central processing unit acts as the brain of the robot. In other words, a CPU is the robot component that provides feedback to outside stimulus. All organisms function and survive by using feedback. It's what causes us to whip our hand away after we have touched a hot wave. The CPU in a robot takes in environmental data using sensors and then calls on its programming to perform the appropriate action. A robot's programming isn't a physical component, but it's still an essential part of the whole. Each of the components of robots either take stimulus or provide a form of feedback. The program within a robot provides the logic that drives these behaviors. including if this then that functionality like in smartphones and smart homes. Robots contain logic trees that gather and analyze task and environmental data and then choose an appropriate response based on that stimulus. For example, if a robot approaches a steep drop off, it will back away automatically. A robotic probe exploring another world may activate a different tool depending on what its cameras and sensors detect around it. Sensors Sensors are the powerhouse of a robot's feedback mechanism. They act like eyes and ears to help the robot to take in information about its surroundings. Robots typically incorporate a wide range of sensors type to help them perform their work. These include light sensors, sound sensors, temperature sensors, contact sensors, proximity sensors, distance sensors, pressure sensors, and positioning sensors. Therefore, these are the different sensors which are used in the robot to sense different things, that is light, sound, temperature, contact, proximity, distance, pressure, and position. Now actuators. Actuators means driver. If sensors are the eyes and ears of the robot, its actuators function like muscle. Actuators are small motors attached directly to the structure of the robot that facilitate movement. Some of the most common types include hydraulic, uses oil to facilitate movement. Pneumatic, uses air to facilitate movement. Electric, uses electric current and magnets to facilitate movement. Some of the simplest robots consist of little more than an arm, an actuator, and a tool for performing work. More complex robots may use actuators to kick treads, wheels, or even legs into motion. When robots are developed to complete delicate tasks that require fineness and accuracy, stepper motors are used to achieve movement in specific intervals with repeatability. Use of stepper motors is one of the reasons why robotic assembly took off in such a huge way in the 1960s and never slowed down. Now end effectors. End effectors means gripper. The terms effector and end effector are sometimes used interchangeably. Both terms refer to the tools aboard the boat, that is, the tools that perform the actual work and interact with the environment or a workplace. Factory robots may feature end effectors such as welding torches, screwdrivers, rivet guns, and paint sprayers. Mobile robots usually have manipulators and grippers for lifting objects or disposing of dangerous ordnance. Robots like those dispatched to other planets may carry shovels, drills, hammers, cameras, lights, and other analytical implements. From simple to complex, effectors allow robots to carry out their specific tasks with precision. Now, robot specifications. This is the website. Afterwards, we will see that how the robots are specified. In general, first specification is axis. A robot axis represents a degree of freedom. A degree of freedom determines an independent motion of the robot. The more axis a robot has, the more flexibility or movement it will be capable of. Most industrial robots have between 3 to 7 axes. It is important to consider the number of axes when selecting a robot, an industrial robot, as it will determine its range of motion. 6-axis robots tend to be the most common since they have a high level of flexibility, making them capable of performing complex applications. More simple applications may require less range of motion, which is why the 4-axis Fanuc M410 IC185 is popular for basic robotic palletizing tasks. When you will see the actual figures, then you will understand where we'll see this website afterwards. Now payload. Payload capacity represents the maximum amount of weight a robot arm can tolerate. Robotic payload is typically expressed in kilograms. Payload varies greatly among industrial robots from 0.5 kg to over 1000 kg. Considering the workpieces as well as the weight of any end effectors integrated with the robot will help guide you to selecting a robot with an appropriate payload capacity. For instance, if your application involves palletizing boxes, the Fanuc R2000IB/125L would be an ideal option with its heavy lifting capabilities. Repeatability. Repeatability references a robot's ability to return to the exact same position over and over. In other words, it defines how precise a robot may be. Repeatability is expressed in millimeters plus or minus the point of alteration to determine the robot's margin of error. The Fanuc M20IA has a repeatability of plus minus 0.08 mm. This means its arm will fall within 0.08 mm of the programmed position with each cycle run. Now reach. Reach means a robot's reach may be broken down into two types, vertical and horizontal. Vertical reach determines the maximum height a robot arm can obtain when extended upward from its base. Horizontal reach defines the maximum distance obtained from the center of the robot base to its wrist. A robot's reach can determine the scope of its work envelope. Now next is robot mass. Robot mass is the weight of a robot. It is usually expressed in kilograms and references the weight of the robotic manipulator only. This can be important to consider if you are looking to mount a robot on a shelf, table, or overhead. The next is structure. Structure refers to the type of robot. There are many types of industrial robots, with the most common including articulated, delta, Skara, and gantry. Gantry type of robot means crane type of robot, overhead crane. This specification is important because it determines a robot's work envelope and functionality. Articulated robots are generally the most common used in welding automation and robotic assembly. Now this is the front view of a typical robot. In this diagram, it has been shown the different dimensions, that is horizontal and vertical dimensions of the robot. Now this is the base of the robot. Here this is maybe robot is standing or it is kept on the floor. Therefore, from the floor, from the base to this pivot point, distance is 400 mm. From this pivot point to next pivot point, distance is vertical distance 600 mm. And from this pivot point to the center of the arm, distance is 120 mm. Now this white color you may be observing, it shows its work envelope. That is this robot arm. This is horizontal arm, this is vertical arm. Whenever this robot will start working, maximum up to this much radius, this robot can move, or this robot arm can move. This is the minimum. This is the angle through which this vertical arm can tilt from this base, minus 180 degree, then plus 65 degree, here minus 15 degree. Why it is minus? Because when it will rotate anti-clockwise, we are taking negative angle. When we will rotate it clockwise, we will take it angle as positive angle. Now this is the top view of the same robot. From the top view, you may be observing that the angle, maximum angle tested by the robot from either side, it is plus minus 155 degree. Plus means clockwise 155, anti-clockwise minus 155. Then this is the maximum radius. It can be reached by the robot is R1530 mm. This is the minimum radius. Now this is the robot. This is the robot manufactured by this Coca company. The name of the robot is here, manufacturer's company. You may be observing this is known as gripper. This is a wrist. These are the motors. Now this is the typical specifications of industrial robot. Type KR5R, maximum reach 1411 mm, rated payload 5 kg, supply load arm / link arm / rotating column 12 to 20 kg. The supply load arm plus link arm maximum they are not specified. Maximum total load 37 kg. Number of axes 6. Mounting position floor, ceiling. Floor means it can be kept on the floor. Ceiling means it can be clamped to the ceiling in inverted position. Then variant, they are not given variant or different types. Positional repeatability plus minus 0.04 mm. Then controller KRC2 edition 2005. Weight excluding controller approximately 127 kg. Temperature during operation plus 10 degrees Celsius to minus 55 degrees Celsius. Protection definition IP54, IP65, inline wrist. Inline with the wrist. IP means this is internet protocol address is there. Robot go to the classification of robot. Now we'll see this link www.motoman.com/en-us products. See that this is the Yasakawa is the company which manufactures the robot. Their products are industrial robots, collaborative robots, education robots, used robots, software is also there. Then programming, different controllers, functions, peripherals, positioners, vision, different systems are there, robot welding, pin picking, clinical lab, cutting slash trimming, pallet recycling, spot welding. Therefore, these are the different robots they are manufacturing: industrial robot, collaborative robot, education robot, and used robots. Now we will see the specifications of this different robot. Now you just see this is known as EP series. Now for EP series, these three variants are there: EP 4000D, EP H130RLD, EPH 4000D. Therefore, EP 4000D, its payload is 200 kg, vertical reach 2614 mm, horizontal reach 3505 mm. Then EPH 130RLD, its payload is 130 kg, 130 kg, vertical reach 4151 mm, horizontal reach 3474 mm. Now this EPH, its payload is 200 kg, vertical reach 2629 mm, horizontal reach 3505 mm. Now next, this robot is there, GP series. We'll see one specification only. GP4, its payload is 4 kg, vertical reach 1008 mm, horizontal reach 550 mm. Now next, this robot HC series, HC10XP, payload is 10 kg, vertical reach 1200 mm, horizontal reach 1200 mm. Again, now this HP series is there. This robot payload 20 kg, HP20D 880, vertical reach 3063 mm, horizontal reach 1717 mm. Then this Moto Mini, its payload is 0.5 kg, vertical reach 495 mm, horizontal reach 350 mm. Then next is PH series robot, in which first is PH130RF, payload 130 kg, vertical reach 4151 mm, horizontal reach 3474 mm. Then next is this, see these different robots. SDA series, payload 5 kg, vertical reach 1118 mm, horizontal reach 845 mm. This MH series, its specifications, different types are there in between MH. So is the first simple MHJF, its payload is 2 kg, vertical reach 909 mm, horizontal reach 545 mm. Now this is 5G series. Company name is SG series. Sorry, company name is Yasakawa. Series is SG series. It's SG 400. Its payload is 3 kg. Vertical reach 200. Horizontal reach 400. Now these are the robots which are used for assembly and handling purposes. Now this is SIA series. Its payload is SIA 5D. We will take simple. Its payload is 5 kg. Reach
is equal to 1007 mm and horizontal reach is equal to 559 mm. Different types are there in between this. Next is UP series, UP 400 RD2, payload 400 kg, vertical reach 4909 mm, horizontal reach 318 mm. Now these are the robots which are used for assembly and handling purposes. Now these are the robots which are used for welding and cutting purposes. First is AR series. AR series is its basic model is AR700. Its payload is 8 kg, vertical reach 1312 mm, horizontal reach 727 mm. Similarly, this SC welding series is there. Its payload 10 kg, vertical reach 1200 mm, horizontal reach 1200 mm. Then this is known as MA series. Its payload is 6 kg, vertical reach 5615 mm, horizontal reach 312 mm. Therefore, these are the specifications of the robot. How robots are specified. Next is M3 series again. Payload 50 kg, vertical reach 3161 mm, horizontal reach 2038 mm. Then this MS series, payload 88 kg, vertical reach 3751 mm, horizontal reach 2236 mm. Then next is this SP series, basic robot, that is SP80. Its payment is 80 kg, payload is 80 kg, vertical reach 3751 mm, horizontal reach 2236 mm. Now robots are used for packaging and palletizing operations. These are the some robots. This is a Delta robot, MPP series. Now this is MPK series, first robot. Its payload is 2 kg, vertical reach 165 mm, horizontal reach 900 mm. Vertical reach means maximum distance traveled vertically by the robot arm or robot end effector. It is known as vertical reach. Horizontal reach, the maximum horizontal distance traveled by the robot arm or the robot effector from its base. Similarly, this MPL series, payload 300 kg, vertical reach count 3024 mm, horizontal reach 3159 mm. Now this is the Delta robot, Yasakawa. Payload 3 kg, vertical reach 600 mm, horizontal reach 1300 mm. Now next, MVS series, packaging and pelletizing. First is MPK series, payload 2 kg, vertical reach 1625 mm, horizontal reach 900 mm. And this next robot series is there, payload 500 kg, vertical reach 3024 mm, horizontal reach 3159 mm. Now this Delta robot is there, payload 3 kg, vertical reach 600, horizontal reach 1300 mm. Now this MVS series is there, its specifications, payload 6 kg, vertical reach 330 mm, horizontal reach 650 mm. Then again this PL series, payload 320 kg, vertical reach 3024 mm, horizontal reach 3159 mm. These are the different types of robots under this category. Now next classification is painting and dispensing. Robots are also used for spray painting applications and dispensing. Now this EPX series, its payload is 5 kg, vertical reach 1852 mm, horizontal reach 1256 mm. Then next is MHP series, payload 45 kg, vertical reach 5573 mm, 5373 mm, horizontal reach 2700 mm. Means like this, these robots are used for different applications and they are having the different specifications. Therefore, we have seen all the things. Now, I think I have covered again the 2 points, that is history of robots, robot specifications. These two are, and what are the different components of the robot. Now, today we'll see classification of industrial robots. Today we'll see classification of industrial robots. Therefore, robots are classified as per the 5 categories, that is coordinate system, actuation system, control system, and according to programming method. 4 major types of classifications are there. Now in coordinate system, we are having Cartesian robots, cylindrical robot. Cartesian means which is moving along X, Y, and Z axis. Cylindrical robot means Z axis can rotate cylindrically. Polar robot means spherical robot, means arm can move in a spherical fashion. Articulated robot means or jointed robots. Then Scara robot. Then last is Delta robot. This is the classification under coordinate system. Next is actuation system, electric actuation, fluid power. Then control methods, servo control, non-servo control, and second is motion control. And last is programming, in that online programming, offline programming. Therefore, this is the major classification of the robot. Anyone can please confirm whether you are listening or not, Pranay?
Yes, sir.
Whether my voice is audible?
Your voice is very
Hello?
low, sir.
Hello?
Your voice is very low, sir.
Hello? Sunil? Sunil? Pranay?
Yes, sir.
Hello?
Sir.
Hello? Anyone is
Yes,
there? Prajwal?
yes, sir.
My voice is audible, na?
Yes, sir. It's audible, but a little voice is coming. You can speak louder, sir.
It is what?
Now it is clearly audible.
Earlier it was not audible.
It was audible, but the volume was very low.
Okay, okay. Because here the exam is going on, that's why we have to speak in low volume. After 1st October, you will hear at loud volume. Okay. Now we'll see classification. Classification of industrial robots. First is, today we'll see according to coordinate system. Coordinate systems. First is Cartesian robots. Now you just see Cartesian robots means the arm of the robot can move along X, Y, and Z axis. See that this is the base of the robot. This is the horizontal arm. This is the pillar of the robot. And this arm can move up. It will move along this Z axis. And this whole base, it will move along this horizontally. That is means in X axis direction. We are going to see the videos also. Don't worry. Therefore, Cartesian robots, which are also called linear robots or gantry robots, are industrial robots that work on three linear axes that use the Cartesian coordinate system x, y, z, meaning they move in straight lines on three axes, up and down, in and out, and side to side. Up and down means along xy axis, in and out means along z axis, side to side means along x axis. Cartesian robots are a popular choice due to being highly flexible in their configurations, giving users the ability to adjust the robot's speed, precision, stroke length, and size. Cartesian robots are one of the most commonly used robots types for industrial applications and are often used for CNC machines and 3D printing. Therefore, this is nothing but Cartesian robot. They are moving, means their arms are moving along three linear axes X, Y, and Z. There are applications you will find it in CNC machines and in 3D printing. Now we will see some of these YouTube links to understand what is meant by Cartesian robot. See that this Cartesian robot is there. How this is moving. See that this up and down. Now it is going up. It is coming forward. Now see that this is gantry robot. Gantry means crane type robot. See that how this robotic arm moves. Along x axis, it will move vertically also. This gripper is there or end effector. Rack and pinion drive enables the transmission of large forces. See that it's this payload can carry up to 250 kg. This gripper. Length of the horizontal axis. It can be extendable. Various constellations of carriages type. You can mount different carriages. Extremely sturdy with low wear due to hardened guide rails. Door tail guide enables flexible positioning. High energy efficiency by use of planetary gears. Therefore, now another we will see.
See here, partition robot with pick and place application. Here in the box, it has been shown what is actually done. Again, it is picking up another box. Again, it is placing pick and place type of robot. Partition robot with pick and place application. Now next, see that now. This is Yama robot, partition robot. See that how it is moving like this along x-axis like this horizontally. Then this arm is moving along y-axis. Okay, you can see like this only. See that how this base is moving like this along x-axis. Now this movement is z-axis and vertical movement is y-axis. See that how this robot is used. Now next link we will see. See that now these two arms are there. X, again it is coming out. Therefore, again we will see. See that this is Z, vertical is Y, and this is X. Two arms are there. Therefore, this is known as double arm robot. See that it is used for picking up and placing. Pick, place. Pick, place. Pick, place. Now another we'll see here. Any link is there or not? Kuka linear robot. We'll see Kuka. Problem is there or what? See here Kuka. This is the gantry robot.
crane type robot. See that this is X axis. This is Z axis coming forward. Axis 1, axis 2, coming out and going inside. Some problem. Okay. Now I will open this in this Chrome so that okay. Now we have seen this Cartesian robot. Again, I will check. Let it. I will type it here. Cartesian robots. Last link we will see. Then we'll see. We will go to another configuration. Videos. Yeah, more robot will see. First of all, only one link will see this. See that now. Moving along x-axis, coming out, going inside, again moving up and down.
These are nothing but x, y, z coordinates, x, y, and going in and out is, this is the two arms. See that drilling operation is going on. Drilling and screwing. One arm is doing drilling, another is doing screwing operation. Okay, this is nothing but coordinate system robot. Now we will go to next. Cylindrical robot which is moving along y-axis, that is up and down, then z-axis in and out, and this base or this pillar will rotate at an angle theta. That's why it is known as cylindrical robot. And this end effector will trace a cylinder. Its end point will trace out a cylinder. That's why it is known as cylindrical robot. Now, cylindrical robots have a rotary joint at the base and a prismatic joint to connect the links. The robots have a cylindrical shaped work envelope which is achieved with rotating shaft and an extendable arm that moves in a vertical and sliding motion. See that this is extended arm which is moving, sliding, and vertical motion also. This base is there or vertical pillar. It is rotating at the base. Cylindrical robots are often used in tight workspaces for simple assembly, machine tending, or coating applications due to their compact design. Now these are the YouTube links. Separate links we will see here. Cylindrical robots. Cylindrical robots. Now we'll see how cylindrical robots are working through videos. Directly we'll go to videos. First of all, we'll see this link. See that this cylindrical robot is there. This arm is moving up and down. This vertical pillar is rotating in a cylindrical manner so that this arm, end of the arm will trace cylinder. See that this is the arm. This is the gripper. See that
It is rotating also. It is going inside, coming outside. This arm can move up and down. That's why this is known as cylindrical robot. This 5-axis cylindrical robot will see. Same is there, I think. I'll just see this cylindrical robot having 3 degrees of freedom. See that this pillar, it will rotate. This arm can move. It will go inside, it will come outside, and this will again, this arm also move up and down. See that it is now coming down, going up. This is the end effector. Now next is polar robot. It is also known as spherical robot. See that this base is there. It can rotate at the, this pillar will rotate at the base at an angle theta. This arm can move in and out along z axis. Also, this horizontal arm, it will rotate through another angle that is known as angle phi, either clockwise or anti-clockwise. Therefore, we will see polar robots or spherical robots have an arm with 2 rotary joints and 1 linear joint connected to a base with a twisting joint. The axes of the robot work together to form a polar coordinate, which allows the robot to have a spherical work envelope. See that this is the work envelope of the robot. It looks like spherical shape. That's why it is known as spherical robot or polar robot. Polar robots are credited as one of the first types of industrial robots to ever be developed. Polar robots are commonly used for die casting, injection molding, welding, and material handling. We will see polar robot now. Geared spherical robotic arm mechanism. I will see here. Please stay 1 minute. Problem is there. Okay, now I will. I think this link is not opening. Polar robots. The next is articulated robot. See that this is articulated robot. 3. If this robot can move, means 3 rotary joints are there at the base here and here also. At the base, this link is also moving like this in at angle phi, and this arm also moving at an angle psi. Articulated robots mechanical movement and configuration closely resembles a human arm. The arm is mounted to a base with a twisting joint. The arm itself can feature anywhere from 2 rotary joints up to 10 rotary joints, which act as axes, with each additional joint or axis allowing for a greater degree of freedom. Most articulated robots utilize 4 or 6 axes. Typical applications for articulated robots are assembly, arc welding, material handling, machine tending, and packaging. Now, these are the links. We'll see again whether they are opening or not. Articulated robot. One rotary joint. So that this is second rotary joint. This is third rotary joint. That at the base also printing is there. Here also printing is there. Printing rotary joint. Yeah, this is also rotating. One rotation means one axis. Remember, one rotation means one axis. But how much axis this robot is having? 1, 2, 3, 4, so 4, this is 5. One rotation means one axis. Remember. One, two, three, 4, 5, 6. This is 6 axis articulated robot. Then it is rotating. articulated robot arm works. See that robot Hanuk Corporation. We will see now this video. This is big video, but we'll see only part of it. See that how this robotic arm is there, which is in almost 2.3 ton. This robot can carry 2.3 tons payload, the biggest lifter. I think it is not working. Articulated robot, no? Articulated robot. We will see this small video. See that articulated robots. It is manufactured by this Angel company. Industrial robots for flexible handling tasks and precise parts processing. See this. See, all these articulated robots are there. Gripper technology for fast transfer of thin organosheets. Same. The biggest lifter in the range, ideally suited to heavy weight material handling applications that require an even stronger wrist. This machine will easily lift and position an entire car or load bulky set castings onto machine fixtures. See that this Fanuc. Fanuc is the company which manufactures the robot. This is articulated robot. This is the wrist. This is known as wrist. Similar to our human arm. Articulated robot is similar to our human arm. Our wrist is also rotating. Therefore, this is also rotating. See that? This is international robot exhibition is there in Hanover. See that this robot, it is picking and placing, picking, placing, picking, placing, picking, placing. See that picking. This is blue color. It is known as gripper.
Add is there. See that this robot, this vertical pillar, this horizontal arm, this is wrist, this is end effector. Programming is going on. Now see this robot, how it is used in CNC machines for taking out machine component. Fanuc robot controlled. See that this robot again, how it is moving. See that how it is picking. And placing. See that it is removing that big part from the wall and it is keeping on the table. Now this KUKA is another company which manufactures the robots. See its robots, articulated robots. See now this robot is lifting part from the CNC machine and is keeping on the table. Hello? Hello? Whether you are listening?
Yes, sir.
Hello?
Yes, sir.
Pranay?
Yes, sir.
Hello?
Yes, sir.
Okay, now I will take next robot. SCARA robot. SCARA is an acronym that stands for Selective Compliance Assembly Robot Arm or Selective Compliance Articulated Robot Arm. SCARA robots function on three axes X, Y, and Z and have a rotary motion as well. SCARA robots excel in lateral movements and are commonly faster moving and have easier integration than Cartesian robots. Typically, SCARA robots are used for assembly and palletizing as well as for biomedical applications. I will see it separately. SCARA robots. SCARA robots. See this SCARA robot. We'll see. It is manufactured by Fanuc. High speed pick and place with Fanuc SR3A SCARA robot. See that SCARA robot. How it is picking and placing. See here. Now next is see that this is also SCARA robot. Stacking poker chips. Therefore, this is nothing but SCARA robot. Now next robot we'll see Delta robots. Delta robots or parallel robots possesses three arms connected to a single base. See that 1, 2, 3. These three arms are there. They are connected to the single base here, which is mounted above the workspace. This is mounted above the workspace. Delta robots work in a dome shape and can move both delicately and precisely at high speeds due to each joint of the end effector being directly controlled by all three arms. Delta robots are often used for fast pick and place applications in the food, pharmaceutical, and electronic industries. We'll see the animation of Delta robot. Delta robots. See this. We'll see small video speeding up Honeytop's pancake production. How ABB Robotics are helping Honeytop Specialty Foods Limited. ABB is the robotic manufacturing company from Sweden.
Here inside Delta robots are there. Reduced labor cost, improved health and safety. See that how these Delta robots are working. Okay, we'll see another robot. Delta robot kinematics. See that this. See that this Delta robot is there. See that now how this Delta robot is there. Is working. See that how Delta robot is working. Now this is the Delta robot. Now this next is actuation system. This we'll see in the next lecture. Now we'll stop here. Please enter your numbers.